One thing that distinguishes a good programmer from an average one is that a good programmer often thinks of edge cases. What I mean by an edge case is uncommon scenarios. An average programmer often assumes the end user enters values into the forms the way the programmer expects, but the reality is different. So back in the example from the last lecture, look at the first line here. We have a list of 6 numbers. And in the second line, we want to get the 3 smallest numbers in this list. What if we only have 2 numbers in our list? So I'm going to remove these 4 numbers and run the application. The application blew up. We got an exception. So close the program. We got argument out of range exception. Index was out of range. So what's going on here? When you face situations like this, that's when you start debugging. So I'm going to run the application in the debug mode and find where in the code we're getting this exception, what line. So remember our shortcut, F5 to run the application in the debug mode, Control F5 to run the application without debug mode. So I press F5 now. Okay, we stopped at this breakpoint. I want to continue execution. So in the last lecture, you learned about step over, step into, and step out. There is one more way to continue execution, and that is continue till the next breakpoint. So I can press F5 again, and look, now we are at our second breakpoint. So far, everything seems to be fine. We didn't get an exception. So let's continue. F5 one more time. Okay, we're back on this line again. One more time. Doesn't seem to be right. You know what? I want to get rid of all these breakpoints and just run the application and see where exactly it blows up. So this is something that often comes up when you're building big applications. You put various breakpoints here and there, and once you fix the bugs, you forget to remove them. And then these breakpoints get in the way. So how do we find them and how do we remove them? We go to debug. One way is to go straight here and click delete all breakpoints or disable all breakpoints. That's the quick way. There's also another way. You can go to Windows and breakpoints. So here you see all the breakpoints in your application. What file, what line, what character. You can double click, go there. You can disable them or enable them, or you can delete them. So I'm going to delete both of these. Now I want to restart the application. The shortcut is Control, Shift, and F5. If you ever forget these shortcuts, you can always find them. Just go to the debug menu here. So look, we've got continue, which is F5, stop debugging, which is Shift and F5. And now I'm looking for restart, which is Control, Shift, and F5. So I restart the application. Okay, this is where it blew up. So I put a breakpoint here as my starting point. F9. Now let's look at the exception, argument out of range. So what's happening? Let's close this. Look at this list. This list is empty. There are no elements here. Yet we're assuming min is the first element in the list. So this code is not really reliable. And this is one of those areas that separates an average programmer from a good programmer. Now, before we fix this bug, let's see why is this list empty. If you remember this line, the purpose of this was to remove the smallest number from the list. And we continue repeating this until we get enough small numbers based on the value of count here. So as we are removing these numbers from the list, at some point, the list becomes empty. In this case, because our list originally had 2 numbers in it, after 2 iterations, the list became empty. And that's why we get this exception. Now, the question is, how do we fix this bug? We have a few different ways here. One way is to have an if block in the getSmallest method that checks if the count that we pass here is greater than the number of elements in the list. The reason we're getting this exception is In this case, we want 3 small numbers, but the list is only 2. So this is one way to solve this problem. Another way is to put a conditional in getSmallest method. So we need to check that if the list is empty. So if the list is empty, what should we do? Should we return 0? I don't think so. Imagine if our original list, this list here, had a number of negative numbers. Then at some point, we get here, the list is empty and we return 0. So the program ends up displaying 0 as one of the smallest numbers in the list, which did not exist in the list in the first place. Another option is to check if the list is empty here, throw an exception. So that's one of the conditions or criteria for this method to do its job. This is what we call defensive programming. So when we get input here, before doing any processing, we want to make sure that the input satisfies some criteria. If not, we're not going to continue processing. Now, there is a third way here. Can you see that? It's not quite obvious, but yet it's very important. Look at this method, getSmallest. This method has a side effect. So, this original list that we sent here, we're continuously removing some numbers from it in order to calculate the smallest numbers. And side effects are not good. They make your methods unreliable. And they're often hard to find bugs that are because of side effects. Now, for a second, I want to stop the debugger here. I'm going to put those 4 numbers back here. So if you run the application now, everything works. Okay, we got 1, 2, 3. But let's iterate over the original list. So I'm going to change this to numbers. Look at the result. Our original list is changed. 1, 2, 3 is removed there. And this is what I meant by side effect. So, in my opinion, that's a more serious problem that we need to address first. Now, that may or may not solve the bug that I introduced at the beginning of this lecture. That's fine. If it doesn't fix it, we're going to continue debugging and find the right way to fix that bug. So the first thing I want to do here is to remove the side effect. How do we do that? So in the getSmallest method, instead of removing these numbers from the original list, I want to create a copy of this list to do my processing. So I call this list buffer. So we create a new list and pass that original list here. And then instead of removing these numbers from the original list, I remove them from the buffer. And one more change here. We need to change this list to buffer. So now look, this list, the original list, is only used during the creation of the buffer. Now let's run the application. Okay, beautiful. The original list is not affected. So we removed the side effect. Now let's get back to the original bug that I introduced at the beginning of this lecture. So I'm going to remove these 4 numbers and change the for each block to look at the smallest numbers. Let's run the application. Okay, we still have a problem here. So in the next lecture, I'm going to show you how to fix this problem.